Hi guys, so today we're looking at probability tree diagrams. So this is basically using information that is given to draw a tree diagram. So not an actual tree that grows on the ground, but you're basically just showing the information in a short form. Okay, so we're just gonna go straight into this. Please like, subscribe and share. My camera is a bit blurry. Okay, there we are. So question 1, it says Nicola is going to travel from Sweden to London by train. The probability that the train will be late leaving Sweden is 1/5. So if you remember in my last video on the probability, I think the very first video basically, so if there are two events happening, okay, mutually exclusively, then that means that the probability that one is happening and the probability that the other is happening should add up to make 1, right? So right now the probability that the train will be leaving Sweden is 1/5. Thinking about it, that means that the probability that the train will not be late leaving Sweden is 4/5. So I'm just going to show you that here. So probability that it is late leaving Sweden is 1/5. Okay, therefore the probability that it will not be late leaving Sweden is 1 subtract 1/5 be 4/5. Okay, so if you are struggling with how we got 4/5, it's just 1 subtract 1/5. Okay, now I'm not going to go into this in detail. If you need to understand how to subtract fractions from a whole number, please go to my videos on fractions. So let's just bear this in mind. So these two data we're going to be using as part of our tree. Okay, so flicking to the next page, still talking about this train that is late or not late to Sweden. So if the train is late leaving Sweden, then the probability that it will arrive late in London is 7/10. So that means that it leaving late in Sweden will affect it arriving late in London, or it leaving late in Sweden may not even affect arriving late in London. So the probability that it will arrive late in London is 7/10. Okay, now that is if it is late leaving Sweden. So I'm going to put that in bracket here. Just to take you back really quickly, right? Remember we have two events that are possible. It's possible that it is late to leave Sweden, and the probability of that is 1/5. Now it is possible that it is not late leaving Sweden, the probability of that is 4/5. Now if it is late leaving Sweden, okay, so if it is a 1/5, that means late leaving Sweden, then probability that it will arrive late in London is 7/10. Now if it is late leaving Sweden, which is 1/5, the probability that it will not arrive late in London is 1 minus 7/10, that's 3/10. Okay, so you can remember 1 minus 7/10 is what gave us 3/10. If you're struggling with that, please look at my videos on fractions. Okay, so that's 8 arriving late in London. That's our information there. If it is late leaving Sweden, remember late leaving Sweden is 1/5. Okay, so just going to keep that aside over there. Now, here it then carries on saying, if the train is not late leaving Swindon, the probability that it will arrive late in London is 110. So remember we said, bring us back here, probability that it is not late, no, not London, probability that it is not late leaving Swindon is 4/5, right? So I'm going to come down here, not late leaving Swindon, that is 4/5. So if it is not late leaving Swindon, the probability that it will arrive late in London is 1/10. Now if it is not late leaving Swindon, probability that it will arrive early or not arrive late, so arrive not late to London would then be 1 subtract 1/10, which is 9/10. Okay, so we've not built the tree yet, but we are working our way up to that. Now, all of that information that you're seeing or reading there seems to be too much, so we compact it into this one here. So this is the tree diagram. Now, it started with it leaving Swindon, right? Now, it either leaves Swindon late or does not leave Swindon late. Okay, now if it leaves Swindon late, we were told, so I'm going to bring back the worksheet we used earlier. So yes, leaves Swindon late 1/5. That's it there. So let me just put that in properly so it's clear. Now sometimes they'll fill in some of the data for you and expect you to complete the rest. Now thinking of your fractions, what would you add to 1 to make it 5? Before. So probability that it does not leave Swindon late is 4/5. Now, if we forget about this bit, so I'm going to close this bit for a minute. So if it leaves Swindon late, right, the probability that it will arrive in London late, remember we discussed that earlier, so it leaves Swindon late, which is 1/5, so that it arrives late in London would then be 7/10. Okay, so leave Swindon late 1/5, then you just follow that arrow, arrive in London late is 7/10. Now it is possible that it leaves Swindon late but arrived in London not late, so you work that from here. Okay, what would you add to 7 to make 10? 3, so 3/10 is probability that it does not arrive London late. Now we've discussed what happens if it leaves Swindon late, but what if it leaves Swindon not late? Okay, that then is 4/5, right? Now if we come back to that information there, it says the train is not late leaving Swindon, so that's that 4/5, we've got it here. Now if it's not late leaving Swindon, the probability that it will arrive late in London is 1/10. So I'm going to close this. Right now what you're looking at is probability that it is not late leaving Swindon. So if it's not late leaving Swindon, the probability that it will arrive late in London is 1/10. So we'll put that here, and then that then balances the probability that it will arrive not late in London 9/10. Okay, so that's pretty much it for question 1A. Now question 1B then carries on to say, work out the probability that Nicola will arrive late in London. Now we're going to take this step by step. Okay, the probability that Nicola will arrive late in London. Now there are two things. So this is late in London. Just 1 second. Okay, so late in London if she leaves Swindon late. Late in London here if she, sorry, my camera is a bit blurry. I'm trying to focus it a little bit. Okay, I think that should be clear now. Right, so if she's late leaving Swindon, she'll arrive late in London. So basically, this is what we're looking at here, because the question says arrive late in London, right? So this is your focus. Late in London. Okay. Or late in London. This one here. Okay. So you're either following that there or following that there. Now, so she either leaves Swindon late and arrives late in London, or leaves Swindon not late and arrives late in London. So the key thing is arrive late in London, right? Now to do that, we then do, so you say the probability that she leaves Swindon late and arrives late in London, or she leaves Swindon not late and arrives late in London. So the key thing to remember there is that in both cases you want her arriving late in London. Now, when you deal with probability, and means multiplication. So I'm going to introduce a bracket there, and I'm going to introduce a bracket here. Okay. So probability that she leaves Swindon late, 1/5. Okay, so late, leaves Swindon late, 1/5. Now don't forget to use the bracket. And in probability means multiplication. Then probability that she arrives London late. So if she leaves Swindon late, she arrives London late, 7/10. Or in probability is addition. Now probability that she leaves Swindon not late. So this is leave Swindon not late, 4/5. And multiplication. Probability that she arrives London arrives London late if she leaves Swindon not late. Just go to Swindon not late and head towards London late. So 1/10. Now we can solve a fraction. 1/5 times 7/10. So 1 times 7 is 7. 5 times 10, 50. Plus 4 times 1 is 4. 5 times 10, 50. So denominators are the same. So just add the numerator. 7 add 4 is 11. So we have 11/50th as our answer. That's the probability that she'll arrive London late. Now, we'll move on to question 2. I've only gone through question 1 and it's already about 15 minutes. So, we have about 8 questions or 9 questions to go through. So I have a feeling that I might have to split this video into 2 parts. I hate doing that, but It is what it is. Okay, so straight into question 2. William has two 10-sided spinners. So basically, two spinners, right? Well, two spinners. This one is 10-sided, this one is 10-sided. That's the meaning of that. William has two 10-sided spinners. The spinners are equally likely to land on each of their sides. Okay, so this is equal, it's not biased. Right. So let's go to the next page. So these are the two spinners here. So two spinners, each of them are 10-sided. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10-sided. So spinner A, spinner B, and they are both unbiased, so equally likely to fall on each of their sides. Now spinner A has 5 red sides, 3 blue sides, and 2 green sides. Spinner B has 2 red sides, 7 blue sides, and 1 green side. William spins spinner A once. He then spins spinner B once. Work out the probability that spinner A and spinner B do not land on the same color. Interesting. Okay. So when you take a look at that question, right, you're looking at the probability that they do not land on the same color. Now, first of all, A has 5 red sides and B has 2 red sides. Okay. Just bear with me 1 second here. Trying to check something. Hold on a second. Okay. Okay. So A has 5 red sides, 3 blue sides, and 2 green sides. So with one probability that they do not land on the same color, that will be first starting with probability that A lands on red, right? And B lands on blue, or A lands on red and B lands on green. So basically you spin one and then spin the other. So we're going to say probability that, so I'm going to use capital A to identify spinner A, capital B to identify spinner B, right? And then for the colors, I'll use subscripts. Okay, so subscript R, subscript B, subscript green. Now, if the first time he spun the spinner, okay, spinner A, it lands on A. So sorry, it lands on red. Probably that it lands on red. Spinner A lands on red, and spinner B lands on blue. Or when he spins spinner A lands on red and B lands on green. Just remember that the idea is you don't want them to land on the same color. So he spins A first and then spins B, right? Now when he spins A, whatever color A lands on, we need the probability that, you know, it lands on, B lands on a different color. So the first, he spins A, and A lands on red and B lands on blue, or A lands on red and B lands on green. Okay. Or A lands on blue. So there's going to be a lot of ors here because there's a lot of probabilities, chances of it happening. So A could land on blue, and when he does B, B lands on red. Or A lands on blue and B lands on, let's see, so we've done A landing on blue and B landing on red. A lands on blue and B lands on green. Okay, so we've got, yeah. Or A lands on green, right, and B lands on red. Or A lands on green and B lands on blue. Okay, so we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's it. So the key thing is making sure that we include all the probabilities of A. So there's probability of picking a red on A, blue on A, or green on A. But when you pick red on A, there's probability of picking blue on B and green on B, right? Then when you pick blue on A, there's probability of having red on B and green on B. So you just go on like that, a specific pattern, right? Now that we've done all of that, we'll then just use numbers. Okay, if you have watched my first video on probability, you would see where I said that the total maximum possible outcome is your denominator, and your numerator is, the total outcomes is your denominator, and the numerator is the possible outcome that you're focused on at the time. So the probability, the total outcomes here for A is 10, 5, 3, 2, that's 10. So the probability of A landing on red will be 5 out of 10. And remember, we said and is multiplication. Probability of B landing on blue is 7 out of 10. Okay, so we've done that one. Or is addition. Now probability of A landing on red again is 5 out of 10. And it's multiplication. Probability of B landing on green is 1 out of 10. Okay, so we've done this as well. Or is addition. Okay, on to the next one. Probability of A landing on blue is where is that now? 3 out of 10. I keep losing my train of thought. Then probability of B landing on red is 2 out of 10. That's been used. Or means add. So we go to the next one. Probability of A landing on blue, that is 3 out of 10. And probability of B landing on green is 1 out of 10. So that has also been used. Then we have probability of A landing on green and that's 2 out of 10. And probability of B landing on red is 2 out of 10. Okay, that's used as well. And plus the final one, probability of A landing on green, 2 out of 10 again. And probability of B landing on blue is 7 out of 10. Okay, so now that's been used. Now we solve. So 5/10 times 7/10. 5 times 7 is 35 over 10 times 10, 100. Plus, so that's done. 5 times 1, 5 over 10 times 10, 100. Plus 3 times 2, 6 over 10 times 10, 100. 3 times 1, 3 over 10 times 10, 100. 2 times 2, 4 over 10 times 10, 100. Let's cross that one out. And then plus 2 times 7 is 14 over 10 times 10, 100. Okay. Next is we have this, all the denominators are the same, so 100. So we just add everything at the top together. So which should look like this. The denominator is 100. Okay. So we have 35 plus 5 plus 6 plus 3 plus 4 plus 14. So if we add all of that together, 35 add 5 is 40 plus 6, that's 46, plus 3, and that is 49, plus 4, that is 73, 53, and then plus 14 should be having 67 hundredth. Okay, so that's our answer here, 67 hundredth. So that's the probability that the spinner A and spinner B will not land on the same color. Now, moving on to question 3. Right, I'm most likely going to stop on question 3 because this has gone up to 28 minutes. Okay, so there are 4 bottles of orange juice, 3 bottles of apple juice, and 2 bottles of tomato juice. V takes a bottle at random and drinks the juice. Then Caroline takes a bottle at random and drinks the juice. Work out the probability that they both take a bottle of the same type of juice. Okay. So basically, we are looking at the probability that V takes a bottle. So this is one of those ones where you want to be really careful. Okay. Let me see if I am having to do that on the previous page. Okay. So let's say that Viv takes orange juice, right? Because it says Viv takes a bottle at random and drinks the juice. So if Viv took orange juice, the probability of Viv taking orange juice, right, is 4 out of the total bottle that we've got. So first of all, when you work out probability, you need to check what's your denominator, which is what are the total outcomes that are there, right? So 4, 3, 2, 9 bottles, right? So out of 9 bottles, the probability of Viv taking the orange juice is 4. She has 4 chances of taking orange juice, right? So Viv taking orange juice. So Viv, V for Viv, and subscript O for orange. Now, if Viv takes orange juice and she drinks it, so here is the thing. We now want to look at Caroline also taking orange juice. So Viv took the orange juice first and drank it. How many bottles of orange juice do we have left? So Viv has taken 1 orange juice. We should have 3 orange juice left. Okay, so now 3 bottles of orange juice left. Now, what now will be the probability of Caroline also taking a bottle of orange juice? So again, you do the same procedure. Check what's the total possible outcome that we have now. 3 oranges plus 3 apples plus 2. So we now have only 8 bottles left because Caroline, Vivian or Viv has taken 1 bottle. Okay. Now the probability, how many chances does Caroline have with the oranges? She has 3 chances, so there are 3 opportunities for her to pick oranges. So the probability of Caroline taking an orange juice is 3/8. Now, what if when Viv took a bottle of juice, what she actually took was apple juice? So what's the probability? So let's say nobody has taken anything, but we're starting all over and Viv just wants to take a bottle. Probability of she taking apple juice is, the total outcomes that are possible is 4, 3, 2. That's 9. And Viv randomly takes a bottle and it turns out that it's apple juice, so there are 3 chances of her taking an apple juice. Now if after Viv, so Viv has taken an apple juice and we are left with 2 bottles of apples. Now Caroline wants to take apple as well. Probability of Caroline taking apple. So first, how many bottles do we have left? 8 bottles that Caroline can pick from, because 1 bottle has been taken. Now the probability of she taking an apple is 2, because there are only 2 bottles left now that Viv has taken 1. So Caroline has 2, 8. And let me write that properly. So 2, 8. Now, what if, there's a lot of ifs in probability. What if nobody has taken anything just yet, but Viv decides to go first again, and this time probability that Viv takes tomato, so we have 9 possible outcomes there, so 9, and the chances she's got to take tomato is just 2 chances. Okay, so probability of Viv taking tomato is 2/9, right? So Viv has taken 1 bottle and we were left with 1 bottle of tomato juice. Now Caroline then goes in to take hers, and probability that she takes tomato as well is 4, 3, 1. We've got 8 possible chances, so only 8 bottles left, and there's only 1 bottle of tomato, so 1 chance of her taking tomato. Now that we have all of that put out in number, it says work out the probability that they both take a bottle of the same type of juice. Now they didn't tell us if they both take orange juice, or they both take apple, or they both take tomato, but they just say a type, so it could be either any of the 3, right? So because it could be any of the 3, then what we want to say is that the probability will then be that the probability that Viv takes orange juice and Caroline takes orange juice, or the probability that Viv takes apple juice and Caroline takes apple juice, or the probability that Viv takes tomato juice and Caroline also takes tomato juice. Okay, so that then means that we just go back here and plug in the numbers that we used earlier. 1 second. Yeah, there we are. So I'm just gonna try to fit that in the video. So maybe I'll do this. Right. Okay. So we have here probability that Viv takes orange juice 4 nights and is times probability that Caroline takes orange juice is 3/8 or probability that Viv takes apple juice 3 nights and Caroline takes apple as well 2/8, or probability that Viv takes tomato juice 2 nights and Caroline takes tomato juice as well 1/8. Okay, now we can just go ahead to calculate. So 4 times 3 is 12, 9 times 8 is 72, 2 times 3 is 6, 9 times 8 is 72, 2 times 1 is 2, 9 times 8 is 72. Okay, so we just add, because the denominators are the same, and since we're adding, you just take 1 and then 12, 6, 2, 20, 72, and if you want you can simplify. Okay, and that gives you 10, so simplify by dividing by 2, or simplify even further, so 2072 or 5/18. Right, we are going to have to stop there because this video has gone a lot longer than I planned. So what I'm going to do is to complete question 4, 5, let me see how many questions I've got there because I don't even know. Question 4, question 5, 6, 7, 8 and 9. So question 4 to, oh, even 10. Yikes. Okay, so maybe we might just cover 3 questions in our next video and just split it up like that. Because the thing is, for some reason I don't want to rush through the questions. I want to take my time to explain it. So yeah, thank you very much for listening to this, and I shall see you in my next video. Bye.